Right, we're looking at the probability of multiple events happening, okay, and the best thing to do here, and this is linked into tree diagrams actually, but I'm not sure a tree diagram from scratch is that useful. You do draw one, I just kind of think it's a very long and complicated way of doing things. So therefore, what I would do here is say, it says Felix picks one counter, records the colour, replaces. Now, this sort of language, and the second one says without replacement. Okay, replaces then picks another counter. Find the probability that the two counters were the same colour. So, the way I would do it is I want blue, blue. I suppose I could have done that in blue, couldn't I? I want red, red, and I want green, green. Okay, they're what I want. So I always list the outcomes thereafter. Now, the probability of getting blue, blue is 7/20ths, and because of replacement, it's times 7/20ths. 8/20ths times 8/20ths, oops, and we've got 5/20ths times 5. It doesn't seem to like writing 5s, or maybe that's just me being rubbish. Okay, now when I work all of those out, I get 49/400ths, I get 64/400ths, and I get 25/400ths. Add them all up, and what's that? I did that earlier, 138 over 400. Now, that will simplify, but I probably wouldn't bother. It's just another way of losing a mark by making a mistake. Okay. Now, Georgia, however, picks one counter, then without replacement picks a second counter. Alright, oh, I missed an S there. Anyway, right, find the probability that the counters are the same colour. Again, we're looking at blue, blue. Alright. We're looking at red, red. We're looking at green, green. Okay, now this time, because she doesn't replace the counters, alright, the probability changes, doesn't it, for the second pick. So that's what you've got to be aware of, alright. And we've got, what is it, 5/20ths times 4/19ths. So this time, the denominator is going to be 380 in each case, so that's going to be 42, it's going to be 56 3/80ths, and 20 3/80ths. Now when you add them up, you end up with 118 3/80ths. Now again, I wouldn't bother simplifying. Now, part of the reason for showing you essentially the same question, but one with replacement, one without replacement, is showing you that it makes a massive difference to the probability. Okay, they don't give you the same answers, right? But just read the question carefully. It's with replacement, without replacement, or if you're looking at food like biscuits or sweets or something like that, if something's eaten, it can't be replaced. So it's going to change the probability of the second pick.